So today we're going to start a new topic, which is binary search in a LeetCode playlist. It is the first question of binary search, which is binary search. Let's say, for example, the question is find an element in a sorted array. So now let's see. I have given you an array 1, 3, 7, 9, 25, 46. For simplicity, I am giving you a small example, but it can be very large as well also. So now, if I ask you, tell me if 25 is in this array or not. Now you are not a human, you are a computer, okay? And this is not a simple array. This is let's say very large array. You cannot see the whole array in one picture. For simplicity, I have given a small example, but it can be a very large array. So now I ask you, what is 25 is in the array or not? If it is, then give me the index, and if it is not, then give me -1. Okay. So how we will do it? An array gives us random access. Like I can do array of 7th, like 7 index element, array of 12 index element, array of 1 index element. But I don't know where to look because I do not know where this element is, or even if this element is in the array or not. So what I will do simply, I will check one by one. First element 1. Is it equal to 25? No, it's not. Let's proceed. 3 not equal, 7 not equal, 9 not equal, 25 equal. That means we found the array at this index 0, 1, 2, 3, 4 index. So we know that the element 25 is at a 4 index in this array. So we return 4. Okay. But if it wasn't, what if it's 26? So we still go beyond. We check this one, 46 not found. Then we go here, but the array has ended. So that means no element found. So we return -1. Okay. So what we did here was, this was called linear search. This was the first method of searching an element. We check each element one by one till the end, and in case we can find it, then we return -1. So if in this question, let's say if the array was 10,000 elements long, and let's say it was 1, 2, 3, 4, and then in the end it was 10,000. This is the array, and I ask you, is 10,000 in the array or not? So what we'll do it, we'll check 1, 2, 3, 4. You will keep checking. In the end, you will find it. So at the worst case, if the array size is n, then the complexity is O of n, because we check every element at least once. If there are n elements, we check n checks. Total checks we do is n. So for n, we have O of n complexity. Okay. So now, what's the other method? This is good enough, but this is not the best way to find the element. The next method we have is binary search. Binary search can do, if we give it to the n size array, then it can do like searching an element in O of log n, which is way better than this one. I will tell you how later. Okay, so let me erase this and let's start again. Find an element in a sorted array. Sorted array, this is important. Okay, the array needs to be sorted. For unsorted array, let's say the array is 17, 1, 6, 4, 2, 9, 4, 50. For unsorted array, best way is this only, because there is no order, there is no pattern. So we have the order is random. So we have to check each element one by one. But as sorted array has a pattern that each element will be greater than the previous one. So that in that type we can do binary search. Let me explain you in detail. Let's erase all this and start fresh. Okay, so let's say array, we have an array. It is 2, 4, 5, 9, 54, 96, 102. Okay, this is an array. So now I ask you, we already saw the linear searches, check each element, and we have O of n. So now let's try binary search. What does binary search say? Binary search says, we know for sure that the indexes, we know the indices, okay? 0, 1, 2, 3, 4, 5, and 6. That means there are 1, 2, 3, 4, 5, 6, 7 elements, okay? 7. So why not we check the middle element? Middle element is this one. Wait, 6 plus 6 upon 2. No, actually middle element is this. Okay. 7 elements, 0, 1, 2, 3, 1, 2, 3. Yes, this is the middle element. So what we do is, let's say we have to find 96. Okay. No, let's say we have to find 54. So we have this array. We know we have to find this, and we are right now at this. Okay. So now we are at 9 and we want this. That means this is way smaller than this one. So the answer will be greater than this. Like if we have two parts. This middle element divides this array in two parts. One is this 2 over 5, which is smaller than 9, and one is this part, which is greater than 9. So this is 9, this is something that is smaller than 9, and this is something that is greater than 9. So we know that 54 is greater than 9. That means 54 cannot be in this part, because this part is only smaller than 9. So we want 54. So what we'll do is, we will eliminate this area. So that means the answer is definitely in this area. Not in 9, because we check 9. 9 is not equal, 9 is only smaller than 54. That means the answer lies in these three elements. So what we do is, we are at 9, we saw that 9 is not the answer, and smaller elements are not the answer. So now this is the new array. Now we do this again. The middle element is 96. Okay. Now we check 96 and 54. This divides this array into two parts: smaller than 96 and greater than 96 and 96. We know for sure 96 is not the answer because it is not equal to 54. So we reduce this. Now we have two options: either we can eliminate this or eliminate this. So let's check. 54 is smaller than 96, and this is greater than 96. That means the answer will not be in the right of 96. So we eliminate this part. So now this is the only array, and this is the middle element also because this is the array has one element only. So we check 54 equal to 84. We find it. So this is the answer. Then we return the index. Okay. So this was the binary search. At each step, we eliminate the search space by like half. So now let me tell you how is this way better than the ON approach. Let's say like if we have 10 elements, so at the first step we will eliminate 5, only 5 left now. At second step we will eliminate another, let's say 2, so we have 3. Now at the next step we will eliminate 2, then we have 1. We found the answer. Let's say we have 1000 elements. At the first step, we will divide this is the full array, let's say. We will divide the full into two parts and then we will eliminate one. So only one part left. So 1000 becomes 500, it becomes 250, it becomes 125, then 64, then 32, 16, 8, 4, 2 and 1. We find it. If the answer is the array, then we find it. Otherwise, we know for sure it is not in there because when we check this one, and even if this is not the answer, then we know that it is 0, like the element is not the array. Okay. So now you can see for a 1000 length array, we can just do 1 check, 2 check, 3 check, 4 check, 5 check, 6, 7, 8, 9, 10, 11, 12 checks at max. But if it was linear search, then for 1000 element array, we have to do 1000 checks because it is O of n. So that's why this is way better than the ON approach. Let me give you the max example of this. If an array size is 2 to the power 31, which is roughly equal to 2.1 into 10 to the power 9, 2.1 billion. Okay. So to solve this, as we know, at each step we divide the array by 2, array length by 2. So that means log of n with base 2. Okay. So if n is this one, log of 2 base 2 of 2 over 31. As this is same, so we can just remove this. That means 31. So if an array is 2.1 in billion size, then we just need to do 31 checks and we can find any element if it is in the array or not. So that's why this binary search approach is the best in terms of searching a sorted array. Let me give you the code also. Code is very simple. So what we did was, let's say arrays 1, 4, 5, 7, 9. So this is our index. Let's call it L. This is our index. Let's call it H. Low and high. Okay. Low and high. So simply we do a loop of while low less than equal to high. Okay. Loop starts. Now we want a middle element. Middle element is low plus high upon 2. Okay. So now we have the middle element index, and then what we do is we simply do 3 checks. If let's say if the middle element, wait, let's say if the element equal to array of mid. Okay. So now we know the middle element and we also know the target variable which is given in the question. So we check that if, let me erase this. Okay. So after this we check if element, the middle element we have, if it is equal to target, so we just return the index which is mid. Okay. Now in the other case, if the middle element is greater than target, that means middle element is here and the target is even smaller than this, so we eliminate this part. So then we do high equal to mid minus 1, and in the last case if we are at this point and the target is greater than the element, that means we eliminate this part. So we do low equal to mid plus 1. So we do low equal to mid plus 1. Okay. And in the end we return just minus 1. So let me show you how this code works in the real life also. One last example. Let's say the array is 1, 4, 7, 6, 16, 25, 34, 40. So we have low, we have high, then we have, let's say, mid here. So if we know we have target as 34, so the mid is 16 and the target 34. So we do low equal to mid plus 1. Now this becomes low because this is eliminated. So low is here. Now let's say again mid is here. Now we know, let's say the target is 25. So at this point we know this is greater than 25. So we do this. So high becomes here, mid -1. So high is here. High is here, low is here. So we got the answer 25. So this was our O of n binary search approach. Thanks for watching, and I will see you in the next video.